I got the wrong. Oh yeah. Why the camera not on? Why my camera not working? Okay, Clyde. Only can they hear me? Hello, class. Can y'all hear me?
Yes, sir.
Okay, I'm operating from my laptop camera at this time. Normally, I would do the FaceTime camera. Okay. Hmm. All right, let everybody log in. Got 7 people. Mhm. All right, anybody with any questions or whatnot? I know somebody had a question about the password to the test. No, that was my other class though. I don't know what happened with Canvas and the Proctor U. For some reason, sometimes it'll lose the settings. But hopefully, everybody took the test. We're gonna go over chapter 3 this time. We somebody I lost somebody. We somewhat started chapter 3, so let's get started. Let's say I'll minimize this. No, I don't want to minimize it. I'll just move it to the side. I lost it. All right. Okay. So let's first look at the assignments that you will have. All right. And I'll post them at the end of the class period. So you have to pay attention. I'll post. I didn't post last week's because we kind of like just reviewed, got to the end of the chapter and we gave the test. But I'll post them when I post this information, this lecture. It says you're gonna have a WK assignment 4. All right. And write a program. So now you're writing code. Some people, what they do, they just say C out Fahrenheit temperature equals 72. No, I want you to use variables. So 72 will be assigned to a variable. And then based on your research, if you don't know how to do it, you're going to find a formula that will take the number 72 and convert it to the number in Celsius for the Celsius temperature. Okay, so with computer science, you're writing code to do something. You're not just saying output this, output this, output that. All right, you're writing code to generate or to calculate some type of output. So say write a program that will use a module. Now it says a module. So now you're just not writing a program that will give you the output. And we started looking at modules. I'll show you a program. I kind of showed you one last time. Show you a program that deals with a module and how it works. And you're gonna input the data. Oh, let this phone right. Man, let this finish. All right. So now, so what happens is you're gonna write the program and then you're gonna use a module to and it tells you write a module that will actually input the value, well take the value and output the calculated value of the Celsius temperature. All right. So that's what's gonna happen. And then your output should be something like this: Fahrenheit temperature colon, and then you know that was 72, so that's the variable. You print out the value of that variable, and then equals Celsius temperature and whatever that variable was calculated, what that value was calculated into whatever that variable was. All right. And the thing, and then it says make sure you check your results. The reason why that's in there is because if you remember when we talked about integer values multiplied by integer or divided by integer values will result in an integer result, right? Will yield an integer result. So what happens is depending on how you write your formula, you can be a few temperatures or numbers off of your actual output. So that's why I'm saying check your values. All right. So when you're dealing with something like this, you may want to deal with everything in float, so that you can when it multiplies or divide, you'll get the true number that will be calculated. All right. So just be mindful of that. Make sure you check your answer against whatever feature you have to check it. All right. Then you can check it online though by putting in what is 72 degrees in Celsius, Fahrenheit degrees in Celsius. All right. So that's one assignment that you'll have to do. Uh, the next assignment, okay, I think I downloaded it already, but I'll just go ahead on and uh, okay, module assignment. Okay. All right. So what it says is, all right, write a program that will call a function. All right. So you're gonna write the code in your main program, but then from your main, you're gonna call a function that will allow you to input. So all this will be happening in the function. Input two numbers from the keyboard, calculate the product of the two numbers, that mean multiply them, and then print out the product of the two numbers. So that's what you're going to do. So, and this is an example of how the program will operate. Okay. You're going to prompt the user. You are to enter two whole numbers and find the product of these numbers. Then what? Please enter the first number. They enter five. They have a choice to enter whatever they want. Uh, then you enter five, hit enter. Please enter the second number. You enter eight and you hit the enter key. And then you should get the output, the product of five and eight. Now, see here, you remember you have to break up your C outs where five would be the variable that you're printing out. Eight would be the variable, the value of the variable that you're printing out. And then is, and then whatever that variable, whatever five times eight was stored into, you print out that variable. All right. So it tells you the number five and eight are not part of the output string, but rather the value of values that are variables entered when the program is executed. Okay. Any questions so far? Any questions? Now, the next program, so we have three programs. The next program, all right, write a program that will allow the user to input four values. All right. Now, you got to remember, you're writing the program, uh, and I'm giving you the instructions. It talks about functions, but if you notice in this program, it didn't tell you to input the values from a function, right? You're just supposed to write the code from the main. You're going to input four values, like please enter first number, second number, third number, fourth number. But now it says, remember to prompt the user, because if you don't prompt them, they won't know what to enter. Once the numbers are entered, Now you're going to have a function, create a function passing the inputted values, and we're going to go over that in the chapter today. If we don't get to it, I'll leave the assignment up, but I won't make it. How would I say it? I'll leave it up, and then if we have class, well, when we have class on the next class period, we'll go over it, and then I'll I'll actually put a due date, or I will extend the due date so that you can complete it because you'll more understand what's going on. All right. So if we don't get to it today. So it say once entered, create a function passing the inputted values to that function. And we're going to go over how to do that, how you pass a value to a function that will calculate and print the sum. So once I pass these four values to that new function, I'm going to use those values to get a sum, which means add them all up. Find an average, which means add them up and divide it and get add by 4 to get an average. And I'm gonna find a product, which means I'm gonna multiply them all together to get a value. Okay, so those are the three programs. But remember, they're not just programs saying, okay, write this program to do this. All right. Now you have to use functions. And that's only in this section. They talk about functions in chapter 3. Because when you get to 194, you're pretty much always using functions. 193, I kind of give you, if you take my class, I give you a header file, which is a function that you use every time, but we don't write throughout the program, throughout the class using functions until the very end. All right. So now, any questions? Anybody with any questions?
Um,
Yes.
when did you say we're gonna post these assignments so we could look at them
Oh, right after class.
right after class? Okay,
Right. I'm gonna post them after class, and I'm gonna post the lecture because I didn't post the last lecture because we just kind of finished up a few pages in the assignment, and I mean of the chapter, and then you assign the test. All right.
gotcha. Yeah.
Okay. All right. So in the previous lecture we talked about functions. I mean, right? And we talked about we pretty much ended here, and we talked about the advantage of, like, say, having a program where you just have statements after statements after statement. Nothing is broken down. You just follow from one line going down to the next. But we said that what a program can be broken up into modules, and modules, what happens is you normally break it down to where you're saying, okay, these particular statements perform a specific task. So we'll break those up and put those in a module. These here do something different, but do a particular task. We'll break those up. And what end up happening is, rather than seeing your program in this fashion, what you would see is you may have a call for this, a call for this, a call for this, a call for this. So rather than all these statements, you might have call A, and I'm just saying using the word call because that's what's happening. Call B, call C, and call D. So your program, your main program has been pretty much simplified or condensed to where you don't see the actual process that is being taken place, but you may see the function and the name of the function that might describe what is going on in that module. Okay, so it kind of like simplifies the program, give you like an abstract view of it, because if you wanted to see what was going on in module A, you would just go to the module A definition and say, oh, this is what's happening, blah blah blah, and then you go back to the program, and then you can look at, oh, call in module B, oh, this is what's happening in module B. All right. I know now. um All right, and we talked about it. It allows you to develop the program faster. Most times, if it's a large program, you have teams that can be assigned, and everybody is given particular tasks to do, and you put them together, and it's done. All right. Defining a module and calling a module. All right, let's look at that. But let's talk about it first. If to name a module, you name it. Your naming scheme follows the same rules as naming a variable. One word, Let me give it a number and no special characters. All right. So your names are simply the same way. What some people do is, like I say, with your programming what I want to say, your programming identity or your programming the way you come up, your programming, how what that word I want to use, but you coming up with your own identity as to how you write your code. You might say, okay, all of my functions, when I create a function, I'm gonna capitalize all of the letters of the variable or the function name. All right. So now you can differentiate a function name and a variable name. You know, but that's just your programming style. That's what I want to come up and say. So it depends on the person. You might say, well, all of my function names, I'll begin the first letter of the function name with a capital letter and the last letter with a capital letter. So whenever you see that in your program, say, oh, that's my function name. But it just your programming style. Some people just use the same method of creating a function as they do creating a variable. Is it right or wrong? No, it's just your programming style. All right. We'll look at that in a little while. Defining and calling a function. All right. Defining a function, you create your prototype as to how the function is to be called, and then defining the function, you would have to actually tell it what is being done inside the function. All right. So let's give an example. Let's go to Visual Studio, and I'll just choose the sample. Hopefully it'll come up. All right. Okay. So, all right. So I'll take all this out.
Are you sharing your screen? Am I?
Oh no, maybe not. Maybe not. Maybe not because I just started talking. Let's go back. Let me go back here. Let me see if I can bring this up. Right. Nobody said nothing. Boy, I tell you.
I was wondering.
Cause yeah, I was in the notes. I was here looking at this, But like I said, it really wasn't much of nothing. It was basically the same stuff we went over last class period. But yeah, this is where I was in the notes where we got to naming modules names and then defining and calling a module. So this is where we at. All right. Um. So let's get back to what was our visual. All right. So a visual. All right. So I'll just change that out, and I'll take this up. Okay. All right. Now, what I would tell you, I normally tell my class this. I'll take this out. This is pretty much a shell, and I call it a shell because when you're writing your code, if you write the header files that you're using, or you use if it's one, you use the using namespace std, and then your function int main open close parentheses open curly braces to define what the main does, return zero for the int, and then close. This is the setup, and like I say, some people they have them. I saw an error here where somebody had using namespace colon std colon. That shouldn't be. You should know that this is using namespace std. So if you write this, you could run that, you shouldn't get errors, and you know that pretty much I'm on the right track. Now all I need to do is add any other header file that I need, any variables that I need, and my logic that I need. Okay. So this would be somewhat the like I say, just the sample, the prototype of what you would start with. And then from this, you can build on writing the code. And at least you have that much done. Or some people may not have the ending curly brace. But if you write it out and then start plugging in your information, you know you have the setup correct. All right. So now, if I had something in here like just anything, int x equals 5, y equals 2, z equals 3, and I'll put something like total. All right. So now in this function, in this main function, remember we talked about scope a little bit. X is introduced in what? The main function. So X is known, or X scope is what? The main function. Y is being introduced in the main function. So the scope of Y is in what? The main function. Z is being introduced in the main function. So its scope is the main function. Total is being introduced in the main function. So its scope is the main function. So anytime I want to use X, Y, Z in the main, okay, it's okay. Unless I have some other sub level, then it may cause an issue because it's a different scope. But in the main function, all these functions are known. Now, what happens is I can do whatever I want. If I want to find out the total here, I could just say total is equal to X plus Y plus Z. And what? Oh, X is 5, 5 plus 2 plus 3, and it's going to give me what? 10. All right. So now in this function, I could do C out. I'm going to do it like this. Total and space and total and line. So in that main function, all of these variables are known, and then I can print out total, all right, or output total. So if I debug it, it's gonna come up, man, my nose, and it'll give you, where is it? Did I debug it? Oh, it's running. All right, so you have the total, and the total is 10. Now, remember I told you I wanted to output a certain way. So now, if I wanted to say uh 5 plus 2 plus 3, or whatever those values are, equals, and whatever the value is, I would have to do something a little different. So here I would do something like this. All right. I would do something like this, and I'll say X, well, if I could type X, all right, and then I'll stream, and I'll do space, and I'm gonna do a plus sign and a space. So what I'm doing, I'm just inserting a plus sign between all my output, Y, and then what? Double space, double quote space, double quote. All right, and then Z, double quote, right? Oh, I did it wrong. It should be equal. All right. So now when I execute it, you see here? Now, I didn't print out 5. I printed out what? What the value of X was. The plus sign, in order for me to have space in between this equation that I'm outputting, I put a double quote, but I put a space plus space. And then I printed out what? With the value of Y. Notice it's not in double quotes because I don't want to print out Y. I want to print out the value of Y. All right. And then the same thing, the plus sign, and then the 3, which is the value of Z, and then the equal sign, and then total. So see how I'm streaming this new line tab. Then I'm streaming uh, the value of X. Then I'm streaming space plus space. Then I'm streaming the value of Y. So see, I broke it down. Remember, we kind of looked at that at the very beginning of the semester where we had one sentence printed out, all in one double quote, enclosing double quotes. Then we broke it up into 2 or more streams. All right. So Now, this is not the format that you have to output your information with the Fahrenheit or whatever. But I'm saying if you wanted to print out text, all you have to do is put it in double quotes. All right. So you should know how to manipulate that. Because what? If I do this, give you an example. If I put double quotes around Y, I won't get an error here. But when I run my program, when I debug my program, watch what happens. X, I mean 5 plus Y plus 3 equals 10. So rather than printing the value of Y, which is 2, I'm printing out the what? The letter Y. So you got to watch when you're doing this, all right? All right? And it depends on if you wanted to print out the letter Y or you wanted to print out the value. Okay? Everybody understand that? Any questions? All right. So now I'm showing you this because now let's change the program. The program is the logic is basically the same, but structuring the program is a little bit different based on the instructions. Because if I say, okay, now I want the program to be written to where the values are, I mean the X, Y, and Z are entered in that call function, calculated from within that call function, and outputted from within that call function. All of a sudden, now I need to modify this code. Now, the thing is, I didn't say anything about passing variables, so therefore, we know that X and Y would be global to the entire program. All right. Remember we talked about local and global variables. When I declare variables outside of the main, all of a sudden they're known in any function that I have. Okay, so that's one of the keys when you're doing your program. Until I start talking about passing values. When I start talking about passing values, all of a sudden now your variables need to be local to the function where they're introduced, where they're being assigned, and then the value is being passed. All right. So now notice I didn't get any errors, but now I need to pretty much set up my function. So when you create a function, there's three things you pretty much need to do: your prototype, your definition, and your call. Three things. So let's say we do the prototype. Function prototype. Prototype. All right. So our function prototype is how the function is going to be set up. So I'll say void because we didn't talk about passing values or anything. So it'll be void or returning values. Give it a name. I could say I'll say total function. I could call it anything I want, long as it's a valid name. And open and close and semicolon. Now, if you notice, I made everything cap. It's not a problem. I could have did everything lowercase. I could have uppercase certain value, certain letters if I wanted to. But programmer style could be this. All right. So now that's the function prototype. The function definition would go outside of your main body because the main function, the body of the main begins here, the body of the main in here. So let's our function definition. The definition tells us what the function is going to be doing. So here I would do void, and then I'll give my function name total function. All right. Oh, no semicolon. Then, because main don't have it, because I'm defining it. So now I define what this total function is to be doing. So basically, me being a program before, this is what I want the function, total function to do. So what I'm gonna do, I'm gonna cut this out of here and paste it here. So now what? this is the definition of my call function. All right. Now, now the thing is, now I need to find a way from this main to get to execute these statements. So I need to call that function. So I'm gonna put this up here, / function definition. All right, so that's the function definition. So in here, I need to call the function. So to call a function, you would just type in the function name and the open and close curly parentheses semicolon, because there's no arguments because we're not passing anything. So I would do, all right. So now, so what happened? We had a program where we declared our variables, we calculated our initialized our values, we calculated a total, and we outputted this information. All right, but we did it all from within the main, right? Simple program, everything in the main, boom. Now we've done what? We've taken the program, and now from the main function, we define our variables globally first, and then we define or declared our function, and then we say, okay, you don't see anything that's going on in the program, because what? It's abstract to you. All right. If you look at the main function, what's going on? All I know is it's calling total function. What total function is doing? I'd have to go to total function. Oh, it's adding x plus y plus z, giving totals, and then it's outputting x plus, or the value of x plus the value of y plus the value of z, equaling to total. So you see what's happening? Same exact program, different way of writing it. So if I run this program, I'm gonna get the exact same output. Let me close this out. And we run it, it's gonna get the exact same output. You understand? Exact same output, but what? Written in a different fashion. Where what? We took the portions of the program and we are calling it, we're calling a function to execute those statements.
Um, I did have a question. So if you put the function definition above the int main, would it run the exact same?
It'll run. You talking about before main here?
Yeah, like if you just
Yeah,
cut, function definition, that whole section, and put it above main, that way it's all together. Would
right.
it run the same?
That's one way. That's another way of writing a program. Give you an example. If I do that. Now, I tell students though, if you do that and you have like say multiple functions that you have in your program, you have to be aware of the order in which you place those functions, because if I list my functions in an order in where this function introduces a variable that's needed in this function, it won't work. Why? Because it's almost like declaring variables. If I declare variables and then I use a statement for a variable that's declared below it, the program does not know, it doesn't know what the variable does or is, right?
Yeah.
So that's the only downside to just putting all your functions at the beginning. You have to have them in the proper order, because it's almost like saying, hey, I'm declaring this function to be this. Okay, do whatever. I'm declaring this function, do whatever. But if I swap them, I might be trying to use something within that function that's declared in another function below, and all of a sudden now I got to try to rearrange them. But if I just do all the prototypes here, it doesn't matter, because I'm saying I'm declaring all my functions, and now when I call them, everything is known, so I could use them when, how I need to use them. All right. So, and I'll show you. I'm gonna show you that based on what you was talking about, I can take this statement out. All right. I can take that out. So now it doesn't know what this is doing. And I could take this this definition and cut it, all right, and paste it here. I gotta paste it, paste. And now it'll work, right? So it takes the place of this because this just say declare this to be known and to be used. All right. But this says, okay, declare it's almost like initializing a variable or declaring a variable. I can declare something to be used, all right, but then I can initialize it because this actually telling me what it's going to be doing and also telling me what the name of it, right? You got it?
But would you have to like take that int x equals 5, y equals 2, z equals 3, and put it inside of that those curly
Ah,
brackets?
no, because what? This is global. Remember?
Okay, okay, I got you.
Right.
Yeah,
Remember, it's
that goes
global.
through everything.
It's a different thing if it was local. We're gonna go over that too, you know. Because if I just take this statement here and move it inside the main, now it's local to the main, right? And
Yeah,
now, in order for me to use any one of the values of those variables, I'll have to pass those values, all right, to that function. All right.
I got you.
All right. So everybody kind of understand what functions is and how they work. And this is just another way of doing it, right? It's no right or wrong, but it's just another way of programming, all right? But like I say, you can do your prototype, you can do your definition and do your call, no problem. Or you could actually do your function declaration and definition all at the top and then go along with your program. All right. And like I say, you'll get the same result. Let me close this up. Let me close this up here. All right. And I think this may have to be before this. It may not. Let me debug it.
I did have one more question. So,
Right. You see, I got an error.
yeah,
Right. The error here is I'm trying to use X, Y, and Z. See, I'm declaring this function or actually saying, but it's saying, okay, X, Y, and Z. I don't know what it is yet. It's being introduced where? Here. So this statement here needs to be what? Before this. So that what? When it actually looks, oh, what did I do? Let me undo that. So it actually needs to know what X, Y, Z, and total is before I actually run that function. All right. So now it should work because now I have what X, Y, and Z being initialized. So when it look at this function here, it's saying, okay, I know what those values are, and I'll do whatever I have to do when I get down to the bottom. So when I debug it, it should run. All right. See? All right. But like I say, step by step, X, Y, and Z. When they got here, oh, what was X? And it was down here. But now it's above it. I know what X is, I know what Y is, I know what Z is. And then you do your call. All right. So somebody had a question, was asking something.
yeah.
What
My
you
only
got?
question is, if you wanted to make it so the user had to input X, Y, and Z, uh,
Uh-huh.
wanted it to be global through the total program, how would you do that?
All right. To do that, okay, we gave them values here. We don't want that because what? Even if we give them values, they're gonna be what? Overwritten, right? So you can take this out, correct? Right? So now nothing is known, right? The user gonna have to input it. Now, this is the question I'm gonna ask you. Well, no, we're not passing value, so I don't need to ask you that. So then you go into here, then you'll say what? See out. Well, if I could say it. See out. You understand? right?
Okay. And so my only question there is, would those now be known globally throughout the whole program if you
No,
use
look here.
function
Yeah, right. Until you change it. But they're global because of what?
in X, Y, and Z?
Right. Because that's why you introduced them. If you would do a it XYZ in here, they'll be local to the main. And I couldn't use them in this function. You got me? Because if you look at the remember I told you the shell, you got your pound include, you got your username space. This is your global area. Everything here is your global area. And then what? It main. You got me? So it's still set up basically the same way.
Yeah.
Yeah,
Okay.
right. Right. So everybody see that. So I'm gonna go ahead on and add the other two. And let's see. I'm gonna just do a copy and paste. And then I'm gonna change paste and paste. I'll do uh and change this to Y. Change that to Z. All right. So now what I'm doing within that function, I'm what? I'm just retrieving, but it's what? X, Y, and Z still what? Global. So I'm telling it, okay, please enter a value for X. So it knows X is global. I can use it in this function. Whatever I type in is going to store in the X. Whatever I type in is going to store in the Y. Whatever I type in, it'll store in the Z. It's going to take those values, sum them up, and store them in the total, and then output this statement. So if I run this time, it's a little different, but it's still using the function. It's going to prompt me, see, please enter the first value. I'll say 10, 20, and 30. So that should be what? 60, right? Right? So see the difference in the program. The first one, we initialize the values and what? The variables were global. Well, yeah, they were global. And then here we just declared the variables and they still were global, but they didn't have a value, but what's going on? But we assigned the values as we inputted the variables. All right. Let me let that finish. All right. So any questions? Any questions about this? And like I said, we took this function from up here. We commented the prototype, and it was down here. All right, took it from here and brought it to the top because it'll work the same way. I could take this off, and I could take this out. I mean, move this. Uh, hold up, class. Let's see something. Let me cut this, and paste. Hold up, let's see something. Where am I? Here we go. Let's go. Hold up. Oh boy. All right, I'm back. All right. So so I moved it to the bottom. All right. And it's the same, it's exactly the same. Only thing is we added the prototype at the top and the function definition at the bottom. And the program should run the same. All right. Program should still run the same. All right. All right. See, still run the same. All right. Questions? Anybody with a question? Now that's being global. As we get through the chapter, we're gonna look at like say values being local, and we have to pass them. All right. So we get back to the notes. So that's defining, all right, and calling, all right. So that's the difference, defining and calling. Defining would be actually telling it what the program is actually, or that function is doing, all right. This is the definition. Calling is just saying, okay, wherever I'm going to call it from, the name of the function and whatever arguments, which are none, and then semicolon. All right. Now, so
Um,
if you look at this, if you look at this in this book, this is pseudocode. All right. So it just say module, and then it say show messages or message. Now, what happening here is this is the definition where we had void and what total, what we had total function. All right, same difference here, no semicolon. But notice they don't have open curly brace, closed curly brace, but they do have what in module. This is the beginning, this is the end. But we know in C++ the curly braces are the begin and the end. All right, so you don't see the actual syntax, but you see that they have the module name where they're actually telling you what module they're using, and the definition, what's it actually doing, and then ending the module. All right. So in calling the module, same difference. They put the word call. In the program, you don't have to use the word call. You just use what? The module name and open and close parentheses, because there's no argument, semicolon. All right. If you were actually writing the code. All right. But this is just pseudocode. All right. Looking at this. All right. The main module. All right. So it doesn't have what? Pound include IO stream, using namespace, but we know that what? A program would have that. But then what? The main module, you'd have what? Int main, open close curly parentheses. Then what? Open curly braces, in module, close curly braces. Because the main function is a module. It's it's the um it's the module that's used in every C++ program. This every C++ program will execute this module. It'll look for it. You don't have to how would I say, declare this module. It's set up in C++ to look for the main module or the main function, right? So that's why you can't change this name. If I change this to anything but main, whether it's capital MAIN, whether it's just my module, and I'm gonna get an error. The program will look for main, the main module. Okay, once it finds the main module, that's where it starts. And what other function or whatever else you have to do is it will gonna go from there and perform and execute your program. All right. So this is understood. The main function is understood in C++. Okay. Now, so in this main module, it displays I have a message for from you. All right. But then it says what? Oh, call the show message. Where's show message? Oh, module show message. All right. Display hello world. All right. Then I'm finished. It returns back and displays that's all folks. Now, that's one thing you need to understand about modules, and it's about to show you in a sense how it works when you're dealing with modules. And what I'll show you is once a module is completed, the program returns to the calling function and starts executing the very next statement. Okay, give you an example, and I'm gonna do it somewhat like they did it in the program. I'm gonna do something like see out. Okay, calculating uh sum of values. All right. So, and I'll just put two spaces. So, and then after this, I'll put okay. See how All right. So uh so notice what happens here. In this main program, it says it has the first statement, see out, and it's doing 2 lines, then tabbing, calculating sum of values, then 2 lines. Then it's calling the total function. So it's going down here, it's going to execute this, please enter this, please enter that, please enter that. Then it's going to output this plus this equals whatever. Once it completes this function, the program is not complete. It returns back to the calling function, which was the main, and goes to the very next statement and start executing the remainder of the statements that's in C++. If there are none, it's finished. But if there are any, it could be another call. It'll execute that call. All right. So if we look here, it'll return here, then it's going to output, thank you for using this program. So let's run it, man. My nose tripping. Let's run this. So we do a debug, all right, and watch what happens. Look what executed. See? Calculating sum of values. So it executed this statement. Let me go to the main function. It executed this statement. Then it what? It you don't see please enter first value here, but you see the function call. So it went to the function and it said what? Please enter first value. Now, it doesn't just execute the first statement and return back to the main. It has to execute all of this. And then, or if you had a return here, like if I had return at the end of this statement, anywhere I see a return, it's going to return back to that function, that calling function. So the return command does do that. All right. But if you look at this, there's nothing that say return or anything, but you just what? You're going to execute. Oh, I'm at the end, and it returns back to the main function. All right. So this was the statement it executed for the function, and then it's going to execute. Thank you for using this program. So if I put in numbers, all right, see here, it outputted this statement. Then it got to the end. Return back to the next statement. What? Double space, and then what? Thank you for using this program. And then 2 more spaces. Everybody see that? Everybody kind of understand what's happening with the logic, how it works, right? Right?
Yes,
Okay.
sir.
Sir.
All right. So now let's go back to the chapter. So that's what this is talking about. How the program actually executes the statements. All right. So the main module, all right, it goes in and say display this, then it calls this function, and then it executes this. Oh, I'm at the end. It goes back, it displays this, and then at the end, it ends the program. All right. So that's basically what it's saying. All right. And it's showing it again here. Call goes here, ends this. When it ends this, it goes back and displays this, and then it ends. All right. So this just shows you how the function goes back. But if I like I told you, if I had something in here that said footer, if I did something like this, void uh, header void footer. So see, I can add as many functions as I want in the program. Names have to be different, just like with variable names. So what I can do is I could go down here and say, okay, void header. And like I say, a function can be as large as you want it to be. All right, just like a program. So now what I'll do, I'll say, okay, I'm gonna take this statement out and I'll cut it, and I'll put the first statement I had about the program. I'll put it here. All right, and then that last part here, I'll take this out. Okay. Oh no, that's not here. My fault. as here. I'll take this out. Okay. Ah, cut this. And I'll put this here. All right. Now, but it still won't execute this till I until I call it. All right. Until I call it. So now that header was here. So I could go in here and I can say header, right? And then down here, before my return, because I'll in the program, I'll say footer. If I can tell you. All right. So now, so look how it simplified the program. Header. What's going on in header? I don't know here, but I can go to the function. Now, header could be a whole lot of lines of code, a whole lot of couts, a whole lot of whatever, right? But all I see is header. Footer, same thing. Footer could be X number of lines of code, but like I say, all I see is footer. To know what it does, I'd go down here. So what? I simplified my main function to where what? Okay, what's going on in this program? Well, I'm calling a header function, I'm calling a total function, and I'm calling a footer. That's the primary thing that's happening. But what? If I want to know exactly what's going on with header, I'd have to go to the header function. Oh, it's going printing 2 lines, tabbing over, and then outputting this, and then 2 more lines. Okay, what's going on with a total function? Oh, see out this, seeing that, see out this, seeing that, see out this, seeing that. Oh, add this up, put in total. Oh, then print out this. Oh, well, what's going on in footer? Oh, what's going on in footer? Oh, 2 spaces, tab, output this, 2 more align spaces. All right. So if I run it, it's gonna be the exact. Well, we didn't do it yet, but it's gonna be the exact same thing as we see here. So if I do a debug, see here, it's still printing what? Calculating sum of values because what? Header is the up here, the prototype of header. Header is being called here, and then here is what the definition of header is, right? And then they can say we do the actual total function, all right? And then when I hit enter, then it's gonna go back to the main function and it's gonna call footer and then go to footer and return back to the main and end, right? So everybody see what happens, all right? See how I can create this to do exactly what I want, all right? Now, questions. Anybody with questions? Any questions? And like I say, this is with global variables, right? Got to remember global variables. Now, who had asked about that question about putting a header at the top of the function? I mean, of the main, above the main. Who was that? I
Hey,
forgot
Billy.
when somebody had asked that question. But if you look what happens here. Notice how X, Y, Z in total can be introduced after these functions if I just do the prototype, all right? But if I move those functions here at the top, I have to introduce or declare my variables first because they're being used in that header, not that header, in that total function. So if I bring this and put this up at the top, I have to put this statement, I have to put it below this statement. All right. Because what? The variables that's in this function is being declared here. So have to be done before that function. All right. So that's some of the things, like I said, you have to keep that order, but if you don't, you're just saying, okay, these are the variables, these are the functions, that's the prototypes, then the order really doesn't make that much difference. All right. All right. So let's get back to the notes. All right. So now, flow charting a program with modules. All right. This is the module symbol. Okay. This is the module symbol. It's like a process symbol with the two lines on the edge. All right. So you have the double lines and the double lines. All right. So if we look at this program says, all right, it starts at the main. All right. So notice they don't have what begin. It got main because what normally in the like we say, main is understood, right? The main is understood, but it's just letting you know because you're gonna have other functions named that's gonna be in the flow chart. So main, right, and then what display or that see out. I have a message for you. After that, it's calling what show message. So looking at that symbol, you say, okay, I have a function that's defined somewhere. Now, what's the definition of this function? If you look here, you don't have start, you don't have end. You have what? The name of the function, which is the beginning of it. And then you got return, which is the last thing, and then go return back to the what? Calling function. All right. So now what happens is it calls show message, and what it does, it executes hello world, and then return. It returns to the what? The very next executable statement, and the statement is what? Display. That's all, folks. And then what? End. So see, rather than have what this statement, I mean this symbol here, you had a function to call that statement. Okay. All right, so you had a function to call it. So that's how you would flow chart that. All right. Now it talks about top down, and what the idea of top down is what just keep taking your program and keep breaking it down into small segments to where you can have it when you call it these individual functions. All right. So it says the overall task of the program is uh, to be performed is broken down into a series of subtasks. So you break it down, but then you examine it again, and if you can break it down further, you break it down some more. And then once all the subtasks have been identified, or you've broken it down as much as you wanted to, because normally just because you can, sometimes you may not break it down, but it just depends on what you want to accomplish. All right. And then once that done, you know, uh, you have all your different modules, and then that's called the top down approach. All right. So a hierarchy chart. Now, a hierarchy chart is a chart that just simply shows the relationship of the different modules or functions in your program. It does not specify what particular order that a function is being called, but it shows what function is dependent on being called by another function. All right. So, and if we look at this table here, let's look at this. I'm trying to maximize a little bit. So we look at this chart, this hierarchy chart here. All right. So let's look at this chart. So if we look at this chart pretty much, if we look at it by the names of the functions, this chart is just basically trying is a breakdown of calculating a salary, a pay for employees, where they calculating regular pay and overtime pay, or and generating the net pay. All right. So if we look at this, we have a main function. Now I'm gonna ask you, how many functions are being called from the main? Anybody? The hierarchy chart shows the relationship of functions being used in a particular function. So how many functions you think is being called from the main?
Looks like about nine.
How many?
Nine.
Only from the main.
Oh, five.
Five. So what happens is now this hierarchy chart does not necessarily tell you the order in which they are called. You understand? But it tells you that from the main, I'm going to call a get input function. From the main, I'm going to call a gross pay function. From the main, I'm going to call a calculate overtime function. From the main, I'm going to call a calculate withholding function. From the main, I'm going to call a calculate net pay function. Everybody understand that? Now, but if you look at it, it's broken down a little bit further where from the get, once the main called the get input function, somewhere in get input, it's gonna get input gonna call the get hours work function, and it will also call the get hourly pay rate function. Everybody understand what I just said, right? So from the main is gonna call get input, but then from get input is gonna call get hours work, and it's gonna call get hourly pay rate. Again, as I said though, which one of these functions in the get input is called first? Get hours work or get pay rate? You don't know. It's not dealing with the hierarchy of when they're being called. All you know is that that function is being called from within that function. All right. So there's no real order, right? You gotta remember that. And then look here, the calc withholding function. It once it's called, it's also calling the calc taxes and then the calc benefits. Now, which one is called first? We don't really know. You understand? Until we look at the program. But we do know that those two functions are involved are being called by the calculate withholding. All right? Everybody see that, right? Hello? Okay, hopefully
Yes,
everybody
sir.
got that. All right.
Yeah.
So look here. Oh, that's in the note. Hierarchy chart. Okay, main file. The main file is calling how many functions? 5 different functions, right? It's calling the starting message. It's calling step one. It's calling step two. It's calling step three, and it's calling step four. What order are they calling them? We don't know. All we know is that they are related or being called by through from the main function. All right. Give an example. Let's look at this. All right. Let's look at this code. Look at this code right here. So if we were to create a hierarchy chart, how would it look? Who can explain to me how would our hierarchy chart look based on this information here? Anybody? What would our hierarchy chart look like? A hierarchy chart shows the relationship of your function calls. So we would have our main function, all right? Then we would have the header function listed below it, related to it. We'll have the total function below it related to the main, which means it called from the main, and we'll have the footer function below it called from the main. So we'll have those three functions beneath the main function, showing that the main function is calling header, is calling total function, and is calling footers. Footer. Everybody understand that? That would
Yes,
be
sir.
a hierarchy chart. Okay? Calling header, calling total function, calling footer. Now, well, I'll wait till we get to it in the notes because we could change this program up to where it's executing totally different, but it's doing the exact same thing. But we'll get to it a little later. All right, let's see here. So look at well, this just showing. I can't. I can't delete that. Somebody put that. So they're just showing you what's happening. Okay, from the main, I'm calling starting message. But then what? It have other statements in the program. Then it calls step one. Got a program, press a key to see step two. All right, input. Then it calls step two. All right, got some other information that things that going on. Then it's calling step three. and then displaying something, press whatever to get to step 4, input, and then it's calling. It don't have the line here. That's just a mistake here. Calling step 4, and then the program is ending. All right. So now we talked about local variables. Local variables are all the variables that's what? Only known within what? That scope, right? Everybody got to remember that. Only the variables known within that scope. Okay. Now, if we look back at our program, all right, wait a minute. Okay, we got this program here, right? We got this program. X, Y, Z in total are local. Are global. But what if I did this? I did something like in here. I'll do something like, now this is the total function. I'll say it something product. Right? When I do this, product is what? Local or global? Anybody?
It would be
Product?
Local.
local.
Huh?
Local.
Local.
Yeah, it's local, but it's local to what?
The total function module.
Bam. That's right. Any other function does not know product. Give you an example. If I go into here in this function, and I'll just say product equals 5. Look what happens. Because what? Product is only what? Known where? In the total function. All right. But watch this. X is global, right? Y is global, right? If I do something like X is equal to 5, look what happened, right? So X started out as being, let's see where it is. Well, X is local, but like I say, when I execute this function here, I get a value that's stored in the X. But then first of all, it's in header. So I was thinking it's in footer. So in header, we declared that what? X, Y, and Z are known in the program. So what happens is it calls header, and what it does, it assigns X to equal 5. How can it do that? Because X is a global variable. It's known in anywhere in the program. But you saw when I tried to use product, and product was only local to what? To that total function, all right? Module, right? So you got to watch. You got to be very, very careful when you're introducing variables or like say declaring them or whatnot, global and local. Now, but a lot of times that's done so you can how would I say, you can keep the integrity of your values. Because if you had a program that was maybe 1,000 lines of code and you had a global variable and you had several functions, that variable can be changed where? Anywhere in the program. And you may not be aware of it, but you changing the value, you're adding to it, you're doing something or whatever, and then it causing your program to give you bad results. But if you make your variables local only where they need it, and if you need the value to be used somewhere else, past that value, it makes it harder to actually, say unconsciously change that value in your program. All right. So that's one good benefit of that. All right. So local variables and global variables, you got to be mindful. You got to be mindful of that. All right. So look what it says here. What happens here? Name is only what? Local to what? Get name. If I tried to print get name here, it would give an error because, or not to get name, print name, because name itself was declared inside of get name, right? Not inside the main. The scope of name is get name. Anywhere in here, I could use name to do whatever I need to do. But when I go back to my main function, it does not know what name is, all right? Because name was not global, all right? Scope and local variables, which we kind of talked about already. The scope of a variable and what local variables are, all right? So I'll just read. Programmers commonly use the term scope to describe the part of a program in which a variable may be accessed. All right. So the variable is visible only to statements inside that variable scope, which means you can only reference it or use it within its scope. Outside of that, you will get error. So that's all they pretty much saying. Now, it say most programs do not allow you to have duplicate variables, right? All right, because what happens? You'd have to try to allocate a different space for a same variable reference. But when you're dealing with scopes, what? I can have the same name because it's what? It's of a different scope. All right. Give me an example. And it's almost that time, but let's see. Let me close this out and get back to here. Now, so our scope, well, here, it's going to change the program. Let's take this. I'll cut this out. Cut this. I'll cut this here and I'll put this here. All right. Paste this here. All right. So now what? X, Y, and Z in total are known within this function. So I could calculate, do whatever, print it, and I'm getting out. Right? So now, what was I talking about? What were we talking about here? Duplicate values. All right. So now, if I go back here and I'll say, okay, now I'm using X, but X is, we'll say, yeah, I'll say X. X is used inside a total function. So if I go in the main and say int X, right? I could even assign it, right? I won't get an error because what? X in the main is just the scope of the main. X in total function is just the scope of what? Total function. So you see how I did not get an error here because it's what? Two different variables because they're what? They have two different what? Scopes. Everybody see that? Everybody see that? Right?
Sir.
Now, many times you may not want to do that, but I'm just saying though, a lot of times and when we look at passing variables, you could pass a variable from one function to another function using the same variable name because it's what? Two different scopes, right? So that's something. So now we didn't get to the passing of the, oh, see, it's coming up here and it's that time. So passing of the variables. What happens here is there's a cool way of taking values from one place and use them in another. I'll show you this right quick and then we're gonna go. Promise you, promise you, promise you, promise you. All right, so let's get here. So let me remove this. Remove this. But I'll give you extra time to do that last program anyway. But I'll show it so because some people may want to try it. So what I'll do is I'll take this information out. Okay. I'll leave that there. Okay. I'm going to take this out. Okay. Cut this. And I'm going to put this in the main. All right. And paste. All right. So before I call this function here, I got to take X. All right. So before I call the total function, I'm going to declare an X, Y, and Z in total. I'm going to input X, Y, and Z, but then it does not know what's going on here. So watch what I'm going to do and what I have to do. So I need to pass those values, X, Y, Z, and total. Do I need total here? I'll just leave it here just to not get confused. So what I could have just introduced total in the other one in here, but I'm going to leave it. Well, I'll do it. I could say int total. All right. All right. I'll do int total here. All right. So now, so I'll go here because this will be different anyway. So what I'll do here is, all right, what we have to do, we got to find a way to take the values of X, Y, and Z that we've entered here and send them to this function called total function. So normally what you do in your prototype, you say, okay, what I want to pass an int, and an int. So you just tell it what the data types you pass into those variables. Could be string, could be char, could be whatever. But now in my function definition, I gotta tell it int, and then what's the variable that I want to pass it to. And I can use the same variable name, x, int, y, int, z. So what's going to happen? The value for x is going to be passed to the value for x in total function. The value for y going to be passed to the value for y in total function. The value for z going to be passed to the value for z in total function. All right. So now when I do my call here, I have to tell it I'm calling on that function, but I want to pass from the main x, y, and z. All right. Now look what happened. My program. Oh yeah, I'm a X. Oh yeah, it says not global anymore. So I take that out because the X wasn't global anymore. So now what? I wrote my program where I'm inputting X, Y, and Z from the main. They declared in the main as local to the main. I'm taking the values and passing them to the total function, and then I'm passing them into X, Y, and Z. Now you gotta, and that's another thing we'll talk about. Whatever order you pass in this fashion, that's the order you need to set them up here. Otherwise, if I had Z, Y, X here, and this was X, Y, Z, the value of Z would have been put in the X, the value of Y would have been put in the Y, and the value of X would have been put in the Z. So you got to make sure that the order is consistent. Now, when I run this program, all right, so X going to take on X value, Y going to take on Y value, Z going to take on Z value. And remember, we did in total here. We made it local to this, and then we add this and print that. So like when I run it right quick, and then we're gonna go run it, same exact output. Oh well, let's see. You see what I'm saying? So see how programming can become more complex depending on how they want the program written. But like I say, using functions, it makes it your program much more how would I say, you can control okay, X, Y, and Z. I'm just gonna pass those values and they remain in the main function and I could do whatever I have to do with them in the main. All right. So rather than have one large program and you're trying to figure out what's going on in that entire program. Anybody with any questions? Questions? Hello? All right. So what I'm gonna do, I'm gonna post those 3 assignments, and like I say, work on them. The last one, like I say, I'll post it, and I'll just add that extra week to it. But like I say, we'll go over it a little bit more on next week. But the first two, I'm gonna make them do for the next class period. All right.
Do you
Any
mind if
what?
we email you like the assignments before it's due so you can check it over it and make sure we're not completely messing it up?
All right. Yeah. Now what I'll
Yeah.
do, I won't look at it as to say graded. I'll look at it to say, oh, you're on the right track, you whatever, right. Oh, you
Yeah.
got a problem. Right. I'll do that. Correct. Yeah,
Okay. All right.
I'll do that. Right. Okay. Yeah, that's no problem. Yeah. So like I said, if there's no questions, like I say, let me go ahead on and do that now. Okay, here we go, modules and go to this one. Yep. Edit. And what is that? What is that date? This would be what's today? The second. Be the 8th. Okay, so it'll be due on the 8th. Okay. Okay. And no, 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 do that one. And this one I'll push back. All right. So yeah. So now all your assignments have been published, and like I say, work on them. And like I say, programming. Don't just do output this, output. You got to write code, write the logic. All right. All right. So if nothing else, I'll see y'all on next class period. All right. Hello.
You have a good one.
All right. Have a good one.
Thank you, Professor.
You're welcome. All right.